And here we go again, partial fractions, take two. So this is taking it a little bit further, so one step more from what we did last time. But again, nothing overly complicated, nothing you are not going to be able to wrap your heads around and understand. So here we have an algebraic fraction there, but subtle difference this time is that we have repeated roots. Okay, so here in the denominator, that x plus 1 bracket happens twice. Now what that means is that you'll be tempted, why not? You might think that this is a over x plus 1 squared plus b over 2x plus 1. And that'll be a common mistake to make. Because when you have a repeated root like that one there, you have to include a third term. So there will be another term, and what I'm going to do is actually write it like this. Okay, because it could very well be the case that there's a third term there. If I only had those two terms, I could have this situation or that situation there, right? And the point I'm trying to make is that the common denominator of these two fractions is the same as the common denominator of these three fractions. And when I combine them together, which is what we've done here, I wouldn't be able to tell whether I was starting from this point here or that point there. And if I make the wrong assumption of starting from here, chances are I'll get it wrong, because I am ignoring the possibility that I have this third term there. Now, why is it better to start from here? Because if you make the assumption of starting from here, or that this fraction came from only 2, but in actual fact it came from 3 fractions, you'll get it wrong. Whereas if you assume that you come from the more complex 3-term situation, and you in fact came from the second one, you're not going to get it wrong, because when you find b, you will have a value of b of 0, this middle fraction will disappear and it will reduce to the 2-term addition of 2 fractions. I'm hoping that that makes sense. Let me know if it doesn't, but I think hopefully it is clear. All right, so whenever you have a repeated root there, so you've got like a bigger than 1 power, you have to be the square term and then the term in 1. I know where you're going with this. What if I had a cubed? Well, if you had a cubed, you have to have the cube, the square, and the single one, but then that will get too long, and typically you don't get to see those kind of questions. But it would be a possibility. So that is it. The rest we solve like we solve any partial fractions. I'm going to add these 3 terms together, put them with a common denominator, get rid of the common denominator, substitute values in there, figure it out. So that stays as it is. And here I will have a times 2x plus 1 plus b times x plus 1 2x plus 1. I'm hoping that adding those 3 algebraic fractions is not causing anyone any breakdowns. Yeah, and then c x plus 1 squared over the common denominator, which is x plus 1 squared 2x plus 1. Right, and then your common denominators cancel out, and I get my star equation 11x squared plus 14x plus 5 is going to equal a 2x plus 1, b x plus 1, 2x plus 1, and c x plus 1 squared. Okay, and now we're just going to substitute values of x and see what we get. Now, what are the clever values of x to substitute in there? Well, the first one would be minus 1. Because minus 1, when x is minus 1, that term will go to 0, that term will go to 0. So what I've got left is minus 1 squared is 1 times 11, I've got 11 plus 14 plus 5 equals minus a. That should have been a minus 14. Therefore, what do I get? 11 minus 14 is, mental math quickly, minus 3 plus 5 is 2 equals, so a is minus 2. Hopefully, assuming. Right, let's just continue and see what happens. Right, so a is minus 2. What other value am I going to substitute in that? I'm going to substitute x equals minus a half, because minus a half will make these two brackets disappear. So when I substitute minus a half in there, I get minus a half squared is a quarter, so 11 quarters, minus a half, so minus 7 plus 5 equals, that goes to 0, that goes to 0. Minus a half plus 1 is a half. Half squared is a quarter plus is c over 4. Right. 11 quarters minus 2. 11 quarters minus 2 is 3 quarters. Equals c over 4. So c is 3. C is 3. A is minus 2. Okay. And now the problem is I cannot substitute any other value in there because to disappear brackets. So I'm just going to pick one final value of x. Any value will do to substitute. Easiest one to substitute in there. Now that I've got a and c, I can figure out b. So what I'm going to substitute is x equals 0. So when I substitute x equals 0 in my star equation, 0 plus 0, I get a 5. So 5 equals 0 plus 1 is 1 times minus 2 is minus 2 plus, I don't know b, but 0 plus 1 is 1. That's a 1, so I get b. So all of these two brackets become just 1. Because 1 times 1 is also b. Plus 1 squared is 1, c was 3, so 3. So b equals 5 plus 2 is 7 minus 3 is 4. B equals 4. So there you go. That's how you find A, B, and C when you've got a repeated root. Okay, that's how you go about it. And that's your example. And hopefully there shouldn't be anything too complicated there. As always, I would suggest you copy the example out, follow through, see what I've done, repeat it, pay attention, be careful. Let me know if there are any problems, but that's basically it. That is it. Yeah, I can foresee a lovely weekend for you guys.